Good morning. Today we are going to talk about the 6 trigonometric functions of our right triangles. Okay, and when I say that, many of you will probably remember 3 of these: sine, cosine, tangent. You talked about those in geometry probably 2 years ago, maybe 3 depending on when you took it. And all of these I'm guessing you're familiar with. SOHCAHTOA, right? But what you might not be familiar with is that there are also the reciprocals of those, so cosecant, secant, and cotangent. And those are also going to be trig ratios that we'll talk about. So to start off with, there are 3 sides of a triangle, of a right triangle we care about. And we call these our opposite side, our adjacent, oops, that's bad. Let me fix it. Okay. So the opposite side, and that just means, you know what the opposite side of the room, it's across the room. We got to be careful though using that word across because that starts with an A, which will make us think it's adjacent. Hopefully you know adjacent is like next to. And then finally the third side, our hypotenuse. Okay, now the hypotenuse is probably the easiest one to identify. So I always find that first. It does not matter where theta is. If you have a right triangle, you can always go, you know that the hypotenuse will be opposite or across the triangle from that hypotenuse. Okay, so I can put that right here. So H, our hypotenuse, is always opposite of the right angle. Now it's up to you which one you find next. And it doesn't really matter as long as you find both of them. Some of you might like to find the opposite, some might find the adjacent, some might find both at the same time. Okay, so this one down here will be adjacent because theta is right here. Adjacent means next to. There are 2 sides that are next to theta. This side, but we already labeled that our hypotenuse, and this side. This side has to be our adjacent. So that's A, and it is next to theta. Oops. Sorry, I'm about to sneeze and it's bothering me. So next to theta. So that's the symbol, that's how you would spell it, but we'll use the symbol. Okay, and then finally this side is O, the opposite, because it is opposite of theta. Another way to think about opposite is it's the side of the triangle that does not make up angle theta. So it's opposite of theta. Okay, now we have SOHCAHTOA, which you already know. So I'm going to write that over here. It's up to you how you write it. I like to write it kind of like this so we remember the fractions. And then that makes up sine, which is equal to the opposite over the hypotenuse. Now, some of you might be thinking, sine, why'd you put an E there? It is actually spelled that way, but on the calculator, it just has an abbreviation, SIN. Okay, then the second one is cosine. Once again, just COS is what's on the calculator, so I'll underline what's on the calculator. That's A over H. And then finally, tangent, which we know as tan, and that's O over A. Okay, now we also have 3 others. Okay, 3 other type of ratio. So the 3 other ratios are cosecant, secant, and cotangent. Now, each of these I intentionally wrote in the order I did because they will pair up with the one they are across from here. Okay, and it's very easy. To get the other ones, all we have to do is flip them. Okay, so we just flip to get the others. also known as finding the reciprocal. Okay, so what I mean by that is sine and cosecant, they're paired up. Cosecant is the reciprocal of sine. So if you were asked to find the cosecant, you can either find sine and take the reciprocal, or know that it's going to be h over o. Now cosecant on your calculator would be CSC. We can't use cos, COS, because that's already taken. Meanwhile, secant is the reciprocal of cosine, so h over a. Okay, so that's just SEC on the calculator, and then COT on the calculator, cotangent, and that's going to be A over A. Sorry, A over O. It's the reciprocal. Okay, now, when we are asked to find these, okay, the easiest way to find them, in my opinion, is to always start by labeling the triangle. If you label the triangle, then you will be able to easily just match in what each of these is. So always start by labeling the triangle with O, A, and H. I think that's the first step that needs to happen. Once again, I said H is the easiest in my opinion. Just go to the right angle, go across, or opposite. So 5 in this case is the hypotenuse. Also remember, the hypotenuse is always the biggest side. So 5 is clearly bigger than 4 and 3. We know it has to be the hypotenuse. Okay, so that's our H. Now next to theta, right next to it is adjacent. So 4 is A, and then opposite, so 3 is O. Now, SOHCAHTOA, so O over H for sine, so that'll be 3 over 5. Okay, Ka, A over H, so that's 4 over 5. And TOA, O over A, so that's 3 over 4. Now, to find your cosecant, it's simply the reciprocal of sine. We already have 3 over 5, so that'll be 5 over 3. The secant is reciprocal, so 5 over 4. The cotangent is the reciprocal, 4 over 3. All right. So that one was pretty easy. All three sides are there. However, sometimes you will be missing a side. Okay, so if you are missing a side, we can start by labeling if you want. We know this is our H, this is our A, this is our O. But if we are trying to find what sine is right now, to find the sine of theta, I need O over H. I have a 12. I don't know what H is. Okay, so we can use something called our Pythagorean theorem. Okay, you learned this probably back in, I don't know, maybe 6th grade, 7th grade, 8th grade. Then we reviewed it again in geometry. So if you don't remember what the Pythagorean theorem is, it simply is a squared plus b squared equals c squared. That will always be true on a right triangle. Now in this, we got to be careful of the hypotenuse, not because it's the one we're solving here. The missing side is not always c. It's always the hypotenuse that is c. That is our hypotenuse. Okay, so in this case, if we have a squared plus b squared equals c squared, I don't care which one's a and which one's b. I'll just put 5 squared as a, and 12 is my b, so 12 squared equals c squared. Now 5 squared is going to be 25 plus 144. If you can't do those in your head, that's fine. Use a calculator. Remember, 12 squared means 12 times 12. Okay. Now 25 plus 144 is 169. That equals c squared. To solve that, we take the square root. The square root of 169 is going to be 13. Okay, so if that side is 13, now we can go ahead and finish. The sine of theta is 12 over 13. Okay, the cosine of theta will be 5 over 13. And then the tangent of theta is going to be 12 over 5. TOA, so O over A. Now we could have done that one without solving. This one we already had enough information. Okay, and that's not that bad. However, sometimes it will be a little bit more difficult because we have something that's not a Pythagorean triple. Pythagorean triple is when all three of these are whole numbers. Here, do you see one of the sides is the square root of 3? And that will happen sometimes. Okay, if we have a square root that isn't perfect, we don't want to just take a decimal. Okay, for this section, we're going to have no decimals. We're going to go ahead and find what it is precisely. So, no decimals. So what we can do here, we're going to still solve it the same. So square root of 3 is our hypotenuse. This 1 is our adjacent. The missing side is our opposite. We'll still use Pythagorean theorem. So it's still a squared plus b squared equals c squared. A squared can be 1, so 1 squared plus, I don't know what b is, so I'll just put an x there. Now c squared, that's square root of 3 squared. This is what the problem is. Lots of people want to put this right here and solve for c, but we're not always solving for c. We're solving for the missing side, which if it's not the hypotenuse, it's either a or b. So 1 squared is 1. 1 plus x squared equals, now square root of 3 squared, be careful. Square root of 3 times square root of 3 actually is just 3. At this point, we'd subtract 1. X squared will equal 2. We'll take the square root. X will equal just the square root of 2. That's not a perfect square, so we have to leave it as such. Okay, now, it says up here, our job is to find the value of all 6 trig functions. Okay, so let's start with sine. Sine of theta is going to equal, so square root of 2 over square root of 3. Now, right away here, we have a problem. Square root of 2 over square root of 3, that's fine, except we cannot leave a square root on the bottom. Okay, we have to do something called rationalizing the denominator. And it might have been a while since you did this. So after I read this, I'll show you how to do that quick. So if we rationalize the denominator, okay, in order to do that, we can multiply both the top and the bottom by whatever that denominator is, which in our case is square root of 3. The reason I can multiply it and it won't change is if you look, if I multiply by square root of 3 over square root of 3, that's the same as multiplying it by 1. It will change how it looks, but it's the same value. Multiplying anything by 1 does not change its value. Okay, now when I do that, across the top, if they're both on square roots, you can just multiply 2 times 3 is 6. So that'll be square root of 6. On the bottom, square root of 3 times square root of 3 is 3. Okay, so our sine of theta is actually the square root of 6 over 3. And we're done. Okay, now the cosine of theta, same problem is going to happen. This time it'll be 1 over the square root of 3. We can't leave it like that. So if I rationalize the denominator, 1 over the square root of 3, we'll have to times by square root of 3 over square root of 3. I'll get square root of 3 over 3. Okay, so that is my cosine. Now TOA, this one works out. TOA is O over A, so square root of 2 over 1, or just square root of 2 is our answer. All right, now we also need to find our cosecant, secant, and tangent. So the cosecant, remember, is the reciprocal of the sine. So if we think back to what we had, the square root of 6 over 3, if we take that reciprocal, we would have 3 over the square root of 6. We can't leave it like that. So I'd multiply square root of 6 over square root of 6. Now, on top, we have one that's a square root, one that's not. So those just get kind of pushed together. You can't multiply them because one's inside and one's outside. So 3 square root of 6 over 6. Now we can reduce, and it'll be square root of 6 over 2. Now, if we think about it, 3 goes into 3 once, so that's why there's nothing there. 3 goes into 6 twice, but we can't go into that because that is inside the square root. So we leave it as square root of 6 over 2. All right, I'm kind of running out of room here, but after our cosecant, we need to find our secant. So the secant of theta. Now this one, once again, it's the reciprocal up here of the cosine. And we could take the reciprocal of this, but I notice, let's take the reciprocal of what we had originally, because that one we won't have to rationalize. These will switch, and it'll just be square root of 3 over 1. And then our final one with TOA is cotangent, okay, if that pairs up. And that is also our reciprocal of tangent. It was square root of 2 over 1. So if we think about it, in red here I'll do, that would become 1 over the square root of 2. To get rid of that, we multiply by the reciprocal, or sorry, by the denominator twice. We got to rationalize that denominator. We'll get square root of 2 over 2, and we are done. All right. Now, one thing I want to point out before you guys start, so there is a brief Delta Math assignment today to go with this. One of the problems looks kind of like this. It says find the exact value of tangent of A in simplest radical form. So tangent, we know that's TOA. So tangent A, we go to angle A here. TOA, so opposite is the 2. Adjacent is square root of 60. So I'm going to go back here and in the bottom left, I'll do it in black here. You don't necessarily need to write this here, but I just wanted to be able to show you. So 2 over the square root of 60. So to write that, 2 over square root of 60, but we got to rationalize the denominator. So I'll multiply by square root of 60 over square root of 60. And then I will get 2 square root of 60 over 60. And we can reduce 2 goes into 60 30 times. So then we'd have square root of 60 over 30. But we're not done. Square root of 60 can actually be broken down. If I break that down, it is 4 times 15. 4 breaks down 2 times 2. 15 is 5 times 3. Now at this point, I look, and do I have any pairs? I have a pair of 2's. So that pair of 2's comes out front. 2 square root of 15 is what I'm left with. So if I were to rewrite that, I would have 2 square root of 15 over 30. Now to solve that, I once again reduce, and my final answer is actually square root of 15 over 15. Now, maybe that was a little confusing, but square root of 15 divided by 15, I submit the answer, and I'll show you kind of how they talk about it. When they show it, they do that same thing. They rationalize the denominator here. Now, they break down square root of 60 like this, square root of 4 times square root of 15. That's the same thing I did. Now, from their step, instead of circling their pairs and breaking it down all the way, they just know square root of 4 is 2, and square root of 15 is not a perfect square. Okay, so that's another option. Now, at this point, then, 2 times 2 is 4, and then they reduce. So it's the same process. That's 2 different ways to do it. Hope you guys have a great day. Let me know if you have any questions. And